This is old electronics fan, and this is something I picked up recently also. This is an Eico 955. This is a capacitor tester, and this is very interesting because this is capable of doing in-circuit as well as out-of-circuit testing. And from what I can gather, it uses something called a wine bridge. And I'll be honest, it's something I'm not entirely familiar, but a wine bridge differs from a regular bridge in that you got two legs that have resistors in them, and then you've got two legs that have a resistor and a capacitor. And one of the legs is, which would have a capacitor in it, the capacitor isn't there because the capacitor you're testing is the capacitance for that leg of the bridge. And you've got this, which balances the bridge and gives you the readings you want. There's an RC balance, which I have to learn about. Line adjust. This is a problem. There's a couple of problems. I found one of these, but it's not exactly right, because I'm not even sure. This looks like it's designed as a banana plug connection, but it doesn't make any sense. So this is probably not going to work. I thought about putting one of these in there, but they do tell you in the manual that the cable that comes with this is special. It's designed to be used with this. If you don't use that cable, then you have to rebalance this unit in order to get it to work properly. I will have to figure that out. But at this point, I've done absolutely nothing to it. I haven't turned it on. I haven't looked inside it. Nothing. And it's been used. There's a lot of crud on it. But what I want to do now is just look inside it and see what we've got. And let's see here. Okay. And I guess I'll use this. That's the first time I've been able to use that locking container in a while. The reason for that is it was holding parts to another project that I spent forever getting back to. The advantage of that was that when I needed the parts, they were there. It was hard to miss that container, and kept everything safe. There we go. Now, there are a couple of things I'm concerned about with this. One is the cable that's missing. I have no idea why the cable's missing, but because I got this from, well, the guy passed away, but it was from his workshop, and I don't know if he had, for whatever reason, had stored cables elsewhere than in his workshop. I don't know. But this is what I'm worried about. This is an Eico 6FGC6. This is the eye that tells you what's going on, opens and closes. This has, oh, look at this schematic, it will tell me what that is. 6C4, that's a triode. Okay, I think that's what that is. 6C4, yes. And triodes can be used as diodes. Are they doing that with this one? No, they are not. So there's our 6C4. And if they're using it as a diode, they tie two legs together. I believe it's the cathode in the grid. So, I assume this is our, yes, 6FG6. That's our eye. And apparently those are the only two tubes in this. I have no idea how well those hold up over time. but let's see. Excuse. Power transformer, filament voltage, 3, 4, 4, 5. So those are the two filaments. That's how they've drawn it on here. Now it doesn't look like it does not look like there's any DC in here. The bridge does operate off AC, and the frequency and the voltage and the frequency are both matter. One of the adjustments involves measuring the voltage that's being supplied to this and then adjusting things appropriately. So, okay. Alright, well, let's take a peek underneath. I have not done anything yet. Oh, this is kind of nice. We've got a bunch of disc capacitors. Little tiny baby one down there. Let's zoom in a little bit here. So there's a capacitor there, which, that's interesting. But hiding down underneath that one's a little baby capacitor disc. So this is very simple, actually. This is the control that sets the RC balance. Let's learn how to use that. It's got the transformer and it's got 4 lines running out of the transformer, and they're doing some interesting things. Oh, okay. So 2 of those are filament voltage, and then the other 2 are for the actual circuit itself. So let's is this? I think there's a picture of this that tells me what this is, because you've got, that's not adjustable, that is, and so really the only capacitor, well actually let me back up. One of the things I'm going to want to do is check the resistors. Oh, there's a capacitor there too. 0.5 400 volt. And let's see. Yeah, I don't know what that one is. I have to get to that. I'll probably have to unsolder that to check that out. But there's really not a lot here because I've got 1, 2, 3, 4 resistors, 5, and 6. So there's only 6 resistors in this thing. And the only capacitor I'm really worried about is this one here. Maybe that one as well. Now I have heard that disc capacitors have been failing. I'm hoping that none of these do. I don't know how old this is, and I don't know if it's going to tell me. If you got a patent number, I could probably look that up. Let's see. Yeah, it doesn't tell me much. So where I'm going to start, actually, let me see what fuse is in, is good. So, let's see here, get in there. There we are. Now, since this is a potentiometer, I guess I'm going to back this up, I keep getting, since this is a potentiometer, there's 2 parts to this. I'm going to want to clean that just to make sure that behaves, and this also is the line adjust. But this could be fairly simple. The only thing I worry about is this, because I guess I was planning on replacing that with a BNC, and I have a BNC cable, but it might prove to be too long. So I may have to come up with another cable. And I don't think they tell me anywhere what the length of it is. That would have been information that would have been useful information, but they don't seem to provide that. I'll have to try to look around to see if I can get that information before I dig into this much further. But since this seems to be the only adjustable coil, they talk about yeah, that is the only adjustable coil I see in here, so that's what they talk about when they're adjusting for the cable that's on here. So, it can be interesting. Yeah, so, I mean, I can make this work. I can run a center line down to here, and then I can solder the ground to the outside of this. I have shield cabling that I can use for that. I'm very puzzled as to what this is and why it's set up the way it is. Normally, you can take these apart so that you can connect your ground and the center pin. This one, I've looked, you can unscrew this, and this is just a solid piece, so there's no way to get to that. And it looks like, yeah. Huh. That's it. Oh, that's interesting. Let's check this out, because I don't think this is what I thought it was. Let's see. When I look inside there, I see something odd. And the best way to find out what's going on is to use the meter. So we'll do this. We'll do that. Oh, stop it. And now, do this. Okay. Alright, well, I wish I could show you what I see down inside there. Oh, I think I know. Do I have... That is how that works. Now let's find out if I'm right. Because what I was seeing was that there were a couple of arms that came off the center pin, and oh, stop it. There. Well, let's do this. Let's do that, and put it there, and we'll do our beeper. Okay, and make sure it's not shorted. Okay, so that is how this works. So if I want to use that, I can use this. I think I have, this is a mono cable, and that would work with this. Well, we might have an option. I would have to come up with a shielded cable, which I do have somewhere. Okay. Well, of course that leaves just one question. How long was that cable? I don't know that they're going to tell me that, unfortunately. So I'm going to have to explore around a little bit more maybe even if I get a picture of one of these, that might give me some ideas. But while I have this facing you, line adjust, which I'm not sure. I'll have to read the instructions on how you use that. But there's a line adjust control here. You've got three tests. You've got capacity or short, capacity, and open. They've got what they call RC range, 0.6 to 10.5 and 7 to infinite. Then they have RC balance, and this should be the light, I guess. And it is. Looks like it's a neon light. And then of course this is the variable. Oh, that's also, although that sounds wire wound. Yes, I think that's wire wound. So this is where you adjust to see what value your capacitor has. So I'm going to have to play around with this and figure things out. And I guess as a starting point, I could use a known good capacitor, hook that up to this. And there are instructions about the difference between using this to measure capacitors that are in circuit and capacitors that are not in circuit. They also have information in there how to find out just how low the resistance can be that's across your capacitor. Because below a certain resistance, 35 ohms is what I believe I read, although they said it could go lower. If the resistance across your capacitor is below that, this could give wrong values. I just read this, so I'm going to have to go back and review that. So I definitely really would like to be able to use this. I'm very happy. I've had this forever. I've always wondered about this, and it wasn't until I looked inside carefully that I noticed what I thought might be clips that would hold the end of a 1/4-inch jack, and sure enough, interesting. Well, they in the oh wow, it shows up better than having the light on it. Interesting. Anyway, so in the manual they say that if you have the original cable, they say that you should leave the cable connected. Don't disconnect it unless you absolutely have to. So apparently it's kind of a touchy deal here. So, but I've got some homework to do. Okay, so that capacitor seems to be fine. It's newer. There's one resistor that the previous owner had replaced. All the other resistors are within tolerance. I looked on the schematic and they should all be 10% unless otherwise indicated, and there are some with silver on them, but I think they're all within range. You know, maybe these guys, let me just double check those, because those are supposed to be what? Is that brown? Well, let's see what we got here. All right. All right, what are you? 1.6, and it's 1.6 megs. So 10% be 160, so 320, and that's 100K. That's within range. Or no, 10% actually. I'm sorry. 20% is the one without the markings. 10% is silver. Gold is 5. So even at 10%, 160 megs, k ohms rather, would be the 10% on this 1 point. Well, it's actually 150 meg ohms, or yeah, talk. 150K would be the 10% for a 1.5 meg resistor. This is measuring 1.6, so while it's slightly out, it's still within range. I think all the others, I think I was evaluating all of the others as 10%ers, and pretty much all of them were. The only one that was really close to being out is this one, but that feeds the neon light, and not too worried if that's a little bit out. I don't think it's going to hurt anything. Now, I have not plugged this in, so let's find out and see if we've got. Actually, I want to clean that disc a little bit. It should be safe to clean it from the outside. All right. Oh, wow. That's dirty. Looks like whoever owned this might have been a smoker. I didn't smell it, but there's a lot of film on here. Brown film. I see it on here too. So I may want to pull the knobs off and clean this up a little bit. But oh, there's one resistor that I did not check, and I hope I don't regret it. Since everything else is within spec, I'm kind of assuming that one is. But it's on the iTube, and so if I see something that's not quite right with the iTube, then I'm going to have to take that. You solder that resistor, it's got a capacitor across it. So I'm going to have to remove either the resistor or the capacitor, and then I'll check it and see what we got. But I did not do that this time. And certainly I've got lots of time to play with this because I'm going to have to order the right cable for this. So I do not have anything. I've got an RG59 with a BNC connector on it. I'm going to have to check that, but I think, if you remember 59, it was, so there's 3 ohm ranges that I'm familiar with regard to the RG cables that we would normally use. The RG59, 58, we've got RG58U, 58A, and I forget, there might be another one that I'm forgetting. And like I said, there's 3 resistance or impedances, I should say. 50, 52, and 75. Alright. I'm sure that was exciting watching me clean that. So, what I'm going to do is plug this in. I think I'm going to use this because it'll be on my isolation transformer. I'm not going to come up slowly with it because I don't think I need to. Alright. Let's see, we're going to turn that on. Turn this on. And there it is. So this was the part I was worried about, was the eye tube. And okay, just for fun, let's see if we go all the way up. Put that up there, put it on there. Oh, I don't have a cable. I can't test anything. Rats. All right. Well, this is the part I was concerned about a little bit. Because I didn't know how good these fluorescent eye tubes were, but that seems to be looking just fine. So what you're supposed to is put this on short. Can't remember if you short it together or not. But then you do a line adjust to get those 2 bars in, and then you're set to go. All right. So I'm going to order a cable for this. There's really not much else I have to do with this other than maybe a little bit of cleaning, which I will do. And that's definitely very discolored. So this is going to be pretty easy, but the fun part is going to be playing with this, learning how to use it. And do I have a radio? I don't think I have any radios on them at hand in the moment, or do I? Ooh, maybe the American Bosch. I did not restore that radio at all, so that's probably got old capacitors in it that I could test with this. So that's probably what I'll do once I get what I need for this, get it calibrated, and know that it's working. Then my next step will be to play with it, see if it will do in circuit. So what I'll do is I'll test it in circuit, and then test the capacitor in circuit, desolder it, check it out of circuit, and see what we come up with. And there's some mention of a graph which I did not print. I'm going to have to print that. So if you're doing it in circuit, you may have to calculate some stuff. We'll see. I'll have to reread that. But anyway, so that's all I'm going to do for the moment. This is going to be a BNC when I get done. I get the right cable for this, and that's pretty much it, other than learning how to use it. It's a pretty neat little machine. I was intrigued by it when I saw it. Is it going to do what I want it to? Don't know, but it's kind of neat to have this piece of vintage equipment. Love to rescue stuff like this if I can. Alright, well, I'm not sure where I left off, but I did try to get this, check this cord out that I just made. This is, as closely as I could measure it, the specs that they, that I got from, I forget from whom, but so here's where we're at though. I've replaced the old style connector with this BNC. I did have a little short piece of wire hooked between here and here. I decided to take this wire from the original connector and hook it in here. The reason that I did that, and it may be may not be necessary, is because I've run into this kind of a situation similar to this where I had an antenna that I borrowed from something else, and I cobbed it together, and at first I didn't use the wire that connected the antenna to the original device, but I found out that that wire was factored into calculations, of course, for the length of that antenna. And this was for an assistive hearing device where it was transmitting audio to headphones. And when I put that wire back in, when I used that piece of wire that I had taken off, soldered it back in place of my original connection that I had used, suddenly it worked a whole lot better. So that tells me there are times when you really need to pay attention to, it just seems like it's just too, alright, let's go with that. Alright, so there are times when you need to think about things like this because it may affect, especially if length is an issue, it may affect how it works. Now, that may not be my only problem. I haven't gone too far, but what I want to do right now, let's see if we can use something to keep this up where I want it. So what I want to do though, and I'm using this, I've got this right here. Maybe I can slide this over so we're closer to each other. I decided I want to start playing with this, so I've got it sitting on my bench, and I like how convenient it is for me. Now I know it's not as accurate as some of my other meters, but it's close. And unless I'm doing something that really requires precision work, then this will be fine. So if I short this out, and it's 0.1, what are you, 1.3? 1.2? It gets there eventually, 0.12. So what I want to do is, I want to measure this wire. So start with the positive lead, and I'm going to go to this point right here. Okay. Now this wire is not going to read like a short circuit. This is a 50 ohm impedance, so there is some resistance to the wiring. Let's see, this is 58A/U coax, and it's interesting that you can't pin it down, unfortunately, to exactly. I thought this gave me resistance, but the information I got said I wanted a 58 AU, RG 58 AU, and that's what this is. But depends on where you look, whether this is a 50 ohm or 53 ohm, and there's other uncertainties because the information seems to be less than complete or accurate, or I don't know, people seem to have different values for the different standards. I'm not quite sure why that would be. So now, whoops, now what I want to do is check the ground, and that would be this, and I'm going to go here. Okay. Oh, no, stop it. Alright, so 0.23, that should be fine. Just have continuity. Now I want to check to make sure I don't have a short somewhere. And I don't. Let's see. And we'll go here. We have to hit both of them. Oops, come on. And nothing. Alright. So, that's good. Alright. So that's not a problem. But next thing I want to do, I didn't think about this, and the connections in here may all be good. The connections I'm going to be checking may not have anything to do with this and the short setting, because there's 3 positions for this. So let's see, where is this? This is in the middle. So let's check. So I'm looking across these 2 wires, which are currently being shorted by the switch. Okay, so let's check. Let's see. Oh, let's go down here. That'd be better. Yes. All right. Now I could put this on mute tone, but these tips are definitely well worn, well used. But they're what I had. I tried to get some newer tips or newer test probes, and they were such crap, I sent them back. The wire was extremely thin, and because the wire was so thin, it just wasn't going to work well. I was getting resistance from my test leads. So 0.26 thereabouts, it's dancing around a bit. But that leads me to believe that's okay. So let's go down here to this one. And so that's good. Let's go to, alright, let's go down here to this one. Alright. Let's see. I need to see better. Well, so this one, I think I measured, well, let's check this one again. So I just rotated the switch. Come on. Wow, that looks good. So what does that mean for this? I think what I want to do, I don't think this is my problem, but it does not hurt to clean it. Alright, so let's go back to this one and see if I can get this one to behave like that one did, because that was a lot better, it seems. Let's go to here, so I really like, there's a possibility that these rivets are not giving me the same connection. Come on. No. Okay. Yeah, it is better. It is better if I connect to the actual tab than to through the rivets. And let's go here. And come on, let's go. Oh, it's not connected to anything. Alright, try that again. Just trying to rule out any possibility that something here is not working right. And that looks good. And that's the last position. Let's see, let's check this one down here. I don't know if I can't remember if I did this one or not. I think this is the middle. Come on. That looks good. Alright, so I think that part is fine. So next thing we got to do is I want to plug this in. Don't need you anymore. There. Okay, that's where I want you. I have to rearrange stuff here. This is not working well. But that's alright. Now that's on 120. That's where I want that. That will be right now. Then let's see. Now, if I read the manual correctly, it says that, well, let me just double check, because, well, I'm going to turn this on, let it warm up for a minute. Let's see. Yes, that's that there. Infinite. Okay, so this, when I actually turn power on, it will probably work. Okay, so light is on. So there's our scale. Now, what I want to do, general description, no, what I want to do, I want maintenance. Because under maintenance, it should tell me what I need to do to, here we go. Open, test sensitivity. Now, what I want to do, well, select open. Alright, well, that's what they tell me they want me to do. Let's see. Oh, and they want to know what the voltage is, so I gotta straighten this out. They want me to straighten, so they want me to straighten this lead out. Let's see here. Open test sensitivity adjustment. Okay. Now, so right now, I don't have anything, so I'm not sure. straighten the turn slug L1 to its maximum counterclockwise position. Now turn L1 to an extent depending on the voltage that's measured. So I need to know, I'm going to use a newer meter for that. It probably won't matter, but so what they want me to do is they want me to measure how much voltage this thing is actually receiving from the power, from my AC source. Okay, so we'll call it 119. What do they want? Oh, because I didn't have to be that precise. Alright, so if it's 117, I need to turn it half a turn clockwise. Let's just double check that, make sure. Let's go here. Come on. Oh, that's interesting. Really? Huh. If I go here, oh, alright. My probe wasn't, so I was just jumping across here. I was jumping from here to here. And now I got 125. And I go here. It's interesting. So the fuse, the fuse is dropping a little bit of voltage. Yeah, okay. Alright, so we'll call it 125. Alright, now, so just for fun, actually, let's go to AC, the volts. So I've set that up, and I'm just curious to see what this reads. 124.8, no, 123.8. So yeah, it's a little bit off. The other one says 125. We'll go with that one. Now, so here's my adjustment right here. And so what I want to do is I want this to close. Alright, to L1 in maximum counterclockwise position. Okay, and I want this, I guess, if that works. Alright, counterclockwise. We're getting nothing. That's not good. So that's maximum counterclockwise. So am I missing something? Force it, yes, at this point there be some gap. Yeah, there's a big gap. Turn it clockwise until the gap is just closed. So now, oops. I'm not getting anything. And I've got it almost all the way out very closely. So this is not working. Now, I kind of expected this because I saw someone else with one of these, and even though they had the wrong length cable, it was working. But this isn't. No. It doesn't tell me anything about any of these settings. let's see. They wanted me to let it warm up for half an hour before just setting line adjust control. Well, that works actually. But, alright, so let's see. I highly doubt that's going to do anything. No. Let me go back to what I should be doing to adjust the line voltage. Okay, let's find out what they say I should do with that, because that seems kind of important. Okay. Preliminary. Rotate RC balance control clockwise to switch the instrument on. Okay. Set test selector to shorted and short the leads. And that doesn't do anything. Set line adjust control so the green bars close together at the center without overlapping. Oops, not you. And that's not doing anything. Okay, so with that all the way down, the end bars brighten up, but it doesn't come together. So that tells me things are not happy, because it doesn't do anything. Even with the wrong cable, I would think I would get something, but I'm getting no response. So, yeah, so let me run this back up about where it was. I didn't pay that much attention, but no. Yeah, that's not doing anything. So I have a problem. I'm not sure what that problem might be, but I have a problem. So I rewound that back to kind of close to where it was, but now I guess we go into troubleshooting. Now, they tell you once you've got your basic adjustment, they want you to then turn it further clockwise depending on the voltage. In my case, it would be a quarter turn clockwise. And the reason they have you do that is to cover a 10% line voltage variation. Let's see, short test clips. They should open wide. Well, it doesn't seem to matter what I do. I've got this. Is this an open? Yeah. And short them. Nothing. Nada. Okay, so we've got a troubleshooting chart, which I didn't look at beforehand. Maybe I should have, but now one thing I haven't done, although yeah. So the first thing I want to do is I want to look and see if the filament's lit on this, and it is. And since I don't know, I know already that the environment this was stored in wasn't completely dry. So no, they didn't tell me. All right. Let's go to short. Now I should have something happen here, and it should be doing something, and it's not. Oops. Yeah, nothing. All right, so it's not working. All right. Now, two, all right, so they have different things. Works properly in short test, but on open test it does not. Well, what about it doesn't work on either test? I don't. Okay. This is an inoperative pilot lamp and indicator tube glow. Defective tube V1. Okay. Defective capacitor C7. Short pin 6 on V1 chassis. Okay. Now this tells me, well, they give me a test. Alright, now, let's turn this off for a minute. So this could be a quick way to find out if my tube is toast. Because they tell me, on this particular thing, let's come in here. Let's see. Check and replace. Defective test lead or bad contact and input jack. I've checked that. Check by shorting inner and outer conductor terminals with the test in short. Defective S1, which is S1. Where is S1? Which one is S1? Let's see here. No, I want you. Should have a schematic somewhere. There it is. Alright. But this should tell me, where is S1? Tell me. It doesn't seem to tell me that not there anyway. Alright, what is the deal here? Okay. Do not keep it a secret. Where is S1? Now they have some theory in this, which I may have to go and read. And I've got to go. I guess I'm gonna have to find S1. All right. S1 that's the rotary. So I tested that, and it is fine. The other switch is S2, and that's the range switch, which is there. Alright, now, let's go back to our troubleshooting, now that I know which switch it is and that I have indeed tested that already. Oops. Now, in here, so, let's see here. Here we go. Defective C7, short pin 6 to chassis. Alright, let's go to pin 6. And that would be, pin 6 is right there. Oops, right there. And it's a short that chassis. Stop it. Come on. With all the room I've got on this bench, I still can't keep things on the bench. Pretty sad. Alright, so it says 1, 2, 3, 4, 5, 6. So So this should tell me quickly whether or not that tube is toast. And so let's go back and make sure I've got the settings correct. So there we are, pin 6. If I have not screwed up, let's see, well, it's an 8-pin tube, so 7. Huh. 8. That doesn't look right. Why 4? Oh, 7-pin tube. Duh. I'm thinking. I've been around the old 8-pin tubes too long. It's a 7-pin. These come in 7 and 9-pin, and there may be others, but 7 and 9 are the two common ones. Oh dear. Hope this is not going to be how my day goes, where I think the wrong things. Okay, now, let's see. Alright, now, let's see, put that on, let's see. Now, what they say is, once I do that, can I get this? Yes. So, okay. According to the troubleshooting, alright. Defective capacitor C7, short pin 6 on V1 to chassis. Replace C7. Okay. That's interesting, because I thought I checked that. I don't know. Well, let's find out what C7 is. C7 0.05. Okay. What are you? That's 2. Okay. That is, let's find out where C7 is in the schematic so I can make sure I get the right one. Okay, schematic, there you be. And I'm looking at C7, just there, and that goes from pin 6 over to pin 8 of this. Alright, so let's go 0.05, I bet this is it right here. Haha. Alright, so let's see. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's the one. Now, I did not check that. I did not expect I would have to check that. Mistake. That be a mistake. Let's see. It's 400 volts that says there. That's 400 volts that I want. Do I have? Let's see what we have got. I may have to order that. Let's see. 447 is. Alright. Let's see. And I need fires. Since I, let's see. Since my fingers are not made of asbestos, and they don't like getting hot. Let's see. Can I get to this way? No. That's where I want to be. Maybe I can do this. Is that going to work? No. or maybe this will. That'll do it, I think. Alright, so my goal is right there. We're going to get you out of there. And let's see. Maybe I can. Oh, I guess that'll work. Okay. Alright. Now, I think, if I remember right, that what was I thinking? I can't remember now. I got sidetracked already. What was I going to say? Oh, yes. I think these were sold as kits as well as factory assembled, I believe. And I haven't seen anything that tells me that this was home assembled, but if you get a skilled person assembling one of these, you might not know. Ah, there it goes. Alright, so let's start with this. Let's see what we have for value if we do. This is 0.05. Interesting. Interesting. And I've already checked. Let's do our we're going to use our C3, and I want the long cables for this. Of course you can do that fine that way. Guess we'll leave that there for now. That way it can't fall. This is already as far as it can go. Alright. That is an issue. I may wind up checking the tube on this as well, because that is one of the things that they mention in some of the other troubleshooting, which is not surprising. And I'm hoping this isn't improperly assembled, because that means I'm going to have to go through and check the way it's wired. Yeah, that doesn't look bad. Nope. Yeah, that's definitely... Nope. That capacitor is fine. So, why... Let me show you. Let me just show you what I found. Because I didn't show you. But this thing behaves really well. Alright. Can you? There we go. So if we go that way, you can see it flashes. I'm just going to go all the way up. Hey, stop that. Alright, going all the way up to 450. Bam, no problem. Well, just for the fun of it, this is supposed to be an 05. Let's go here. 01 to 05. Nice sharp line. It's dead on. So my C3 and my other modern tool agree. The value is fine. The leakage is not a problem. Therefore, there's nothing wrong with that. that means, let's see, that means I don't need this capacitor that I printed up. So, alright, go back to my troubleshooting chart. I'm betting, I'm guessing that I probably have a dead tube or maybe even a messed up socket. Does it give me voltages? I don't see. So, let's go this way. Sorry. Alright. So this is my schematic. It gives me resistance values. It does not, however, give me voltages. Now, the only tube, well, I can look up this tube and what is that 1,5? Could be 1.5, but what is that? Oh, 1,5 means pins 5 and 1 and 5 are tied together apparently. Okay. Is that how this is wired? No. Let's see. Where's 5? 5 is there. Yeah, no, it's not. So why? Is pin 5 used? Yes, it is. This is a capacitor that goes to chassis at pin 5. And, yeah. So, if I go in here, so we've got pin 7 right there. So 1, 2, 3, 4, 5, and hiding behind this capacitor, so the capacitor goes down to the chassis. 6 is where I tested this out, which is puzzling that this, basically, let me just think about this for a minute. This measures fine, but, is that, I mean, the value is dead on value-wise and it's perfect as far as leakage. Is there any possibility that this isn't healthy, even though, interesting. I'll have to think about that one. But anyway, so this is puzzling because, yeah, 6C4, that is what that is, right? C4. I'm looking at the pins too. Whoops. Darn. Alright, so I'm looking at this pin. This is a 6C4. I'm looking at the pins and I don't see any corrosion there. Everything looks good. That looks fine. Let me back out here. So, just for the fun of it, I want to just put some deoxit. Okay. Alright, so I just sprayed some deoxit on there, and okay. So next I want to put that. Do I want to do that? Do I want to do that? Alright, here's what I think I want to do two things. That, and that. Review. Maintenance. Troubleshooting. Where's my chart? Troubleshooting chart. Where are you? There you are. Alright, so what I want to do is I want to look at this. So, defective. Oh, okay. Defective tube V1. Check and replace if necessary. Defective test lead or bad contact. Defective S1. Defective. Okay, so this was actually the last item on the list. I'm betting defective tube V1. I guess I have to dig out my tube tester and check this. So, alright. I'm glad I reread that because I was going to head down a rabbit hole. And as much as we like those, they're not productive. So, okay. Alright. So I'm guessing that, whoops, come on, no. That's not nice. Oh, I didn't need to put that up there. There. Stop it. Let's go that way, I guess, and bend this around. So, alright. I'm pretty sure I don't have a 6C4. I'll look, but I doubt it. It is not a tube that is familiar to me. Come on. Okay. Let's do this. Yeah, it's hard for me to get this where you can see it, and then for me to actually be able to work on it. We did the there. All right. Yes. I don't want to keep melting my wires. That's not a good thing to do. All right. Good. All right. Next. So let me dig out my tube tester and see how that goes. I'm going to wrap up part one right here. As I was editing, I realized this was going to be a very long video, and I was looking for a good spot to break it, and I think this is a good spot. And in part two, we'll continue troubleshooting and diagnosing to find out why this isn't working.